given the KSP, we'll just take this one here. AgCl is 1.8 times 10 to the minus 10. And this is the KSP for AgCl. When you're writing dissolution equations, dissolution, break it down into the verb. Dissolution is dissolving, okay? Dissolving means you're turning something from solid into liquid. If you're dissolving it in water, it's from solid into the aqueous state, which means you start off with something solid and then you turn it into the ions. When you're writing your dissolution equations, dissolution means you're dissolving. When you're dissolving, you start off with your solid on the left and you turn it into the ions on the right. Silver is a transition metal. So you either remember the charge that it makes, or if you don't remember the charge that it makes, you figure out the charge of the other substance and then balance it, yeah? So let's say, I'm pretty sure you guys know this, but let's say we don't know the charge of silver. Hadiel, what's the charge of Cl then?
-1.
-1. And what's the ratio of Ag to Cl in AgCl?
1 to 1.
1 to 1. So if Cl is -1, then Ag has to be?
+1.
+1, good. So Ag is going to be Ag plus aqueous, and Cl is going to be Cl minus aqueous. When you're writing, anytime you get given a KSP, in an exam context, if you don't know what you're doing with the question, anytime you get given a KSP, KSP comes from a particular expression, okay? Because you sub concentrations into the expression to get the K value. And then the expression comes from the chemical equation, yeah? So this is just for your exam technique, guys. Anytime you're reading a question where there's so much information you don't know what to do with it, you just want to see what you can write out about it, okay? KSP comes from an expression. You can't write the expression unless you have the equation. So even if you don't know what you're doing, guys, if you get given a K, you can at least write out some kind of equation. Can I get a thumbs up, guys? Does that make sense? Even if you don't know how to do the question, if they've given you a K, there has to be a corresponding equation. There has to be, yeah, because it has to come from somewhere, okay? So you can at least write out some kind of equation for it, okay? Good, thanks, guys. Okay, so you get given KSP, you're getting asked about molar solubility. The reason why I'm going through this a little bit quicker is because we went through this last lesson, yeah? So this is just revision. We'll slow down when we get through a new type of question. Solubility is about how much dissolves. And if you're dissolving a solid and it turns into the ions, okay, this is about how much dissolves, which means how many ions get made. Molar, does anyone remember the units for molar from last lesson? It's the same as molar concentration. So what is it? Moles per liter. Thanks, Jay. This is going to be moles per liter. So when the question asks you for molar solubility, they're basically asking you, how many moles of these ions get made per liter? Which is basically saying moles per liter is just concentration. So when they ask you for molar solubility, they're just asking you what's the concentration of ions that form. Yeah, that's all that is. Which means you have no ions at first because it's a solid. And then they're telling you, if they're asking you how many ions get made at the end, that means the ions must have gotten created. So there's none at the start and there's some at the end. So you get given some initial concentrations, you get given some equilibrium concentrations, and that's how you know you need to set up your ice table. So the last inquiry question of module 5 is a little bit challenging to adapt to because you don't have the same vocabulary as you did when you did your regular ice table, which is why it's really important to turn the words like molar solubility into something that makes sense to you. Okay, molar solubility is just how many ions there are at equilibrium, which is the E row in your ice table. You set up your ice table. And what did we say from last lesson, guys? If the question doesn't tell you what you're dissolving it in, the assumption is that you're dissolving it in water. Good. When they don't tell you that you're dissolving it in something, you're dissolving it in water. And Samra, take it away again for me. If I'm dissolving it in water, what must the initial concentrations of these ions be in the water at the start? It would just be 0. Good. Because initial is telling me literally at the very second T is equal to 0 seconds, probably before I even put my solid in. What's the concentration of the ions in there? There are no ions in there because it's just water. So my initial concentration is going to be 0. And then if my concentration is 0, which way am I going to shift? I don't have any ions and I want to make the ions. So I have to be shifting to the right. I'm going to be shifting to the right. Change happens according to stoichiometric ratio. If I have no number out the front, it's a number 1. So Kylie, oh, I got you guys confused with each other. You all start with K. What's my change for Ag plus and Cl minus? If I don't know the particular number, what letter do I normally give it in maths?
Oh, X.
Yeah, good. So I'm shifting to the right and it's going to be X, which means it's going to be plus X and plus X. So equilibrium, 0 plus X is going to be X, 0 plus X is going to be X. My only job now that I have expressions for equilibrium, I'm going to write it into my equilibrium expression, okay? And then I pop my values in. This gives me X and X, which is X squared. And then this is going to be 1.8 times 10 to the minus 10. When you're getting asked to solve for molar solubility, you are solving for X, okay? When you're getting asked about molar solubility, you are solving for X, which means I don't want to write out the whole thing. This is going to be X, and I just square root it. And whatever you pop in your calculator for that, guys, is going to be your molar solubility.